Good afternoon, and thank you for coming back from lunch. You know, whenever I speak at a big conference like this, I always ask them to put me, right after lunch when everybody's a little bit tired, because what I find is the people that come to the session right after lunch are the most interesting, engaged, smartest, best-looking audiences. Don't you think? I think so.
For sure.
So we're really excited about this talk. Ido and I are going to go through how to use HTML5 and App Engine to build modern web applications. So I'm Brad Abrams, and I'm a product manager on the cloud platform team.
And I'm Ido Green, and I'm developer advocate for Chrome.
So Ido, if we're going to talk about HTML5 and App Engine and building great modern web apps, maybe we should define for the audience what a modern web app really is.
Absolutely. So the web is changing so quickly that it's really hard to keep up with all the new capabilities and rich APIs that we're getting every 6 weeks, actually. Things that weren't able to do like 6 or 12 months ago are now able on the web, and we saw in the keynote some really, really impressive demos for that. So when we're coming to define web apps, it's actually quite hard, because we'll see lots of fragmentation on the web. But however, there's few things that we found that are quite common in all the great web apps that are out there today. One and foremost, the first goal of all those web apps is to be as easy as possible for the user to use. They want to let the user achieve their goals with as much efficiency as possible. Some of them are built in offline-first methodology. And what that means is that you're thinking from the ground up how the app will look like and how the app will react when there's no connection, and then building on top of it. So it's not like any other added feature that we want to add to an existing app. It's more of, let's think how this app will work when there's no connection and build on top of it. When we're moving more and more logic to the client side, we're dealing with more code, and that's, I'm sure some of you are smiling, causing lots of spaghetti code. And I think that's one of the main reasons why we see a huge movement and flourishing in MVC, or actually I should say MV star, because we have MVP and MVVM and lots of others that are basically coming to make a clear separation between our data models and our UI, and make our code much more readable and maintainable. The last part is that we want those web apps to feel as native as possible. And we have today with HTML5 all the great APIs to do drag and drop, transition, 3D, and others. We want to reach 60 frames per second. Why? Because above it, the eye couldn't tell. And we want to save some CPU cycles and make ourselves, our users, and Algor happy. So those two parts are extremely important when you are thinking about your great web app. Here is a great example, HipMock. They are basically letting you do one thing and one thing only, find the best flight for your needs. You could see how immersive it is, how functional it is. And if you're setting a new parameters or you just want to start a new search, you don't need to shift focus. You are all in that app. Another great app that I had the pleasure to work with is My Chrome Theme. It's basically letting you create your own personal Chrome theme and share it with friends and family. And I highly encourage you to check it out. It's using all the best technologies, CSS3 and HTML5, in order to achieve this goal. When we're coming to speak about client-side architecture and technology, there's a huge amount of different options out there. And since we don't have time to get deeper, we just choose here 3 great examples to choose from. And if you have a bit more of time, my colleague and great mentor, Eddie Osami, did a great job in terms of letting you know how all the different MV star framework will work in different use cases on a hello world of the MVC framework, which is the to-do list. Why we need offline? It's a question that's coming again and again. And I would just point out that I think the best answer for that will be faster is better. And it's making your app much smoother, much snappier. Users will enjoy it and appreciate it. And of course, you get the benefit that your app will work perfectly when there's no connection or when there is a flaky connection. In our demo later, we'll use Launcher, which is a library that let us actually work in an API that is above the normal APIs that HTML5 let us. And that's another benefit that we wanted to show you, because then later on, if you want to move from, let's say, local storage or web storage to IndexedDB, it's very, very smoothly. Other APIs that are under our hands today, and actually in our toolbox, it's of course AppCache. AppCache is letting you save all the static information that you need. So first of all and foremost, it will be the HTML, JavaScript, and CSS file that we need. Usually it will be one single page app. So it's one HTML file and then a bunch of CSS and JavaScript, but also sounds file and images. And then for saving our persistent and data, we could use local storage, which is a simple key value API, or IndexedDB. And today with HTML5 file API, we could save binary data as well. So offline, we touch about, I think the main challenge with offline is to write the right sync layer. Because to save the data, we'll show you it's quite easy and efficient. The sync is the most problematic way, how it will work best in your use case, and how your user will appreciate the fact, like we saw in the demo today of Google Docs, how easy it is to just notify the user slightly. They could still be productive. They could still work and write their manifesto. But then when we have the connection, we're doing the right thing in terms of syncing it immediately to the cloud. I choose here to show you with one line of code, we could check exactly what is the status. Do we have connection or not? And based on that information, we could make the right decision. Another great feature that Paul Killian worked on is Web Intent. Web Intent basically lets you have the intent system that we saw in Android and have it on the web. And that's, in my humble opinion, going to change the world of web apps, and we're going to see more and more web apps harnessing their users with more functionality without the pain on you, the developers, to code it against the vast majority of API that we see on the web today. Just imagine the power of allowing your users to share anything on their favorite social networks. I know that some of you are thinking, okay, though you're speaking about things in 3,000 feet above, but we have lots of users that are still using older browsers that doesn't have all the capabilities and features that you are talking about. And I choose to mention here because I know that some of the guys are more through the App Engine side and are working in big organization and big enterprise organization. For people that are still have older browser under their hands and heads, they could use Google Chrome Frame. It doesn't need any admin install rights. And once you're installing it, you're getting every 6 weeks the greatest and latest of Chrome, meaning security, speed, and simplicity inside IE. So CSS transition, WebGL, drag and drop, all the great things that you want to accomplish in your web app are there, and they will stay there. All you need is one line of code, one line of meta header, like it's here, or even better, if you have control of your server, just change the HTTP header. And you could choose and play it and tune it to your needs. If you want just certain versions of IE, it will work perfectly. Now, any modern web app, a great web app, need a very strong server. I guess it's just the right time to ask Brad what's new in that kingdom.
Yeah, absolutely. Thanks, Ido. When I talk to web developers, most of them are very interested in a lot of the client-side functionality that Ido just talked about. Building rich, interactive experiences on the client is the way to sort of focus on your users and make sure those needs are met. And so the last thing you want to have to worry about is complexities related to the server. You'd like to just have that taken care of for you. But we do need server environments. You have to serve the HTML, CSS, and JavaScript. You, a lot of times, can offload expensive computations to the server and do those there. You can do sharing and collaboration on the server. But then there's a bunch of problems that you have as a web developer when you're dealing with the server environment. Where are you going to host that? Are you going to maintain your own machine images? What if Linux has a security hole? Are you going to patch that? Are you going to keep up with all that infrastructure that needs to be done? And then it's specifically when you're talking about the new sort of architecture, with using an MVC pattern on the client, communicating to the server via REST APIs, well, how are you going to do that serialization? How are you going to do authentication? How are you going to do things we call the OAuth dance to get user credentials and permissions? So, as you might guess, I have an answer for you, and that's App Engine. So App Engine's been around for several years now. It's a proven technology for building web apps and these modern web apps. With App Engine, it's very easy to build and manage and run your applications. You write code in Java or Python or Go and upload it into our data centers, and Google runs it in our large distributed data centers all over the world. Our SRE team keeps your applications up. Earlier today, we launched Google Cloud Endpoints. And Google Cloud Endpoints makes it significantly easier to build web APIs, to build REST-based endpoints that you expose from your App Engine app and consume that in clients. So you can write your application in App Engine, expose these endpoints via standard REST-based interfaces. We handle the serialization and the authentication, and we give you strongly typed clients for Java, for Android, Objective-C for iOS, and what we'll be talking about here is a modern JavaScript client library that you can go use. And what's great is that all this technology that we're using here for cloud endpoints is built on the same technology. It's the same stack that Google uses to do billions of transactions with our Google APIs, like the Google Plus APIs or many of the other Google APIs that are out there. So you're using the exact same infrastructure and tools, as we'll see. So Ido and I was sort of thinking about what, I don't want to give it away. We were thinking about what we had in common, what sort of demo we should do. We thought the best way to explain this to you, do a demo, so we thought what we would have in common, and we thought what you and the audience might appreciate. So we sort of look at the demographics of I/O, and we came up with a plan, and we decided we would write an app to rate and review beers. So this is the Bira sample application. Actually, if it takes off, you won't see Ido and I at I/O next year, so we'll do our own little startup for beer rating and reviewing. So it lets you enter beers from all over the world. You can review those beers, you can comment on them. And what we're going to do for the next, say, 45 minutes or so is build out this application right here in front of you so you can see how it goes. So let's make sure we understand before we get started the architecture of this app. So the beer applications start with beer. We're going to store the beers, or at least the metadata about the beers, in the largest NoSQL data store in production in the world, and that's in App Engine's NoSQL data store. And then we're going to do some application logic in App Engine to do things like sorting, filtering of those beers, and we'll show you about how that works. And then we're going to expose that over endpoints so that there's a REST-based interface for that. And then Ido's going to consume that in a JavaScript client, a modern JavaScript client using offline and using the MVC framework. OK, so sounds good? Should we get started? OK, so let's get started here. I'm going to start by building out the server side of the application. And what I have installed on my Mac here is the standard version of Eclipse. And then I have the version of Google plugin for Eclipse that just shipped yesterday. So brand new bits. And we're going to use that to start out. So I'll just say new application. We're going to call this Bira. Anybody know why it's called Bira? Hebrew for beer, yeah. And we're not going to use GWT for this, but we are going to use App Engine. And this will create a scaffolding application for us to have us get started. And here it is. Again, this is the server side of the code. And what we're going to do is come in here and add a new class. And as I mentioned, whenever you start with a beer review class application, you got to start with beer. It's central to our application, and it was central to the development of this demo as well.
Absolutely.
So we have this beer class, and this is a plain old Java object. Now we need to think, what is the data about beer we want to store? So anybody got, what do you want to store about beer? Any thoughts from the audience here? Oh, the alcohol content. That's nice. Good. OK. Alcohol content.
Maybe name.
The name. Maybe. That's good. The color of the beer.
Nice.
That's pretty good. OK, yeah, we need a double for the price. OK, so I cheated, and ahead of time, I have a version of the beer that actually works with the rest of the demo. And but it is still a plain old Java object. So what I've defined is just a set of properties that we have, a set of regular fields, and then just getters and setters for that. So there's nothing funny here. Now what we need to do is teach App Engine how to store this object. Right now it's just a plain Java object. We need to teach App Engine how to store that. And to do that, we're going to use the old tried and true JDO. It's been around forever, but it's effective. Everything I'm going to show you, though, works with any persistence layer you'd like to use. You can use cloud endpoints however you want. This just happens to work well for the tool. OK, so we've made it available with JDO. And now we have our object. Now what we need to do is expose this in a way that IDO can consume from his client. So to do that, we'll show off our first new feature of this, which is generate cloud endpoint class. So we'll click on that, and hopefully, yeah, there it goes. We'll generate a beer endpoints class. And in this class, we have this @API attribute on it. The @API attribute indicates that all the public methods on this class will be exposed as REST endpoints. And we'll see how the URL for that looks in a second. And we can change the name of that, which will show up on the URL, to Bira, so it matches. And let's just take a brief look at what we have here. We have a method to list all the beers that are in the data store. Now, we've given you some scaffolding code just to get started with that. And over the course of this demo, we'll go through and modify that. And then when you write your real apps later tonight, or maybe next week, you can modify it. You'll be modifying it even more. So it basically just iterates through the data store and returns all the results. Notice I don't have to deal with any serialization logic or authentication logic. All of that is going to be taken care of for us by the framework. Then I can, same thing, I can get a particular beer by its ID. That code's generated for us. I can insert a beer. And notice this is an HTTP post method. For you people that are REST heads and you're kind of into the REST pattern and making sure that works, we've tried to adhere to it nicely here, and you'll see you have a lot of control as we go through. But one of the things we've done is expose this as a post method because it's insert. And then update is a put, same sort of thing. And then, of course, we have this delete method here.
Remove, but
yes.
I would really, really encourage you to put it as a delete, because it's not only me, but the community will love to have delete here.
Yes.
It will fit perfectly.
Yeah, so the problem is this looks so nice in my Java code. I don't want to mess with my Java code, but I want to change what it looks like for him on the JavaScript side. And so what we have, I'm going to introduce you to this attribute we'll become very familiar with, the @API attribute. And what it does is it gives us a way to customize the REST endpoint that's generated from this method. So in this case, I can change the name to be beers.delete. And that'll give us a nice experience in the Java, iOS, or in our case, JavaScript client that this generates. OK, so I think we have a basic interface here. Let's just do some testing of it. So I spun up the local development time server. So it's essentially a baby version of App Engine running on my laptop here. And then what I'm going to do is use every web developer's favorite tool, curl. We're going to test this with plain old curl just to make sure everything is working nicely before we hand it off to IDO. So the first thing you'll notice, if you're an App Engine geek, you'll notice that _AH. That's the reserved namespace in App Engine. So none of the APIs you're defining here will interfere with the rest of your web applications because we've put them in the reserved namespace. Then we put them in APIs and Bira. If you recall, Bira was the attribute that I put on earlier was there. And then the name of the object is beer. And we just do an HTTP GET to it, and it returns all the beers in the data store, which is none. And notice that the return is a nicely formatted JSON object for us. So let's look at what it would take to add something to that. So let me grab this curl. So we'll do HTTP post and put a new beer in here, and the beer name will be Bud. That's my brother's favorite beer, so trying to give him a hard time.
Be patient.
Patient with him, yes. So what we've seen now is we did a put, HTTP put, got that beer in the database. We got an ID for it, ID 1. And of course, all the other fields are null, but we get a well-formatted JSON object here. Now what we can do is go back and look. The data store isn't quite refreshed yet, but there it is. That returns us a list. And then in true REST style, I can just put a URL parameter passing the beer ID. And of course, there it is. So no surprises there. So that looks pretty good. I think we're almost ready to hand it off. But I thought what I'd show is a little bit more. Right before this talk, I went and deployed one of these to an endpoint. And I just wanted to show you a little bit about some of the infrastructure that's there for you. So if you go to _AH API and then hit the discovery point, for any of your App Engine apps that are using endpoints, we provide a discovery endpoint for that. And that discovery endpoint gives you metadata about, in this case, all of the APIs that are available on that App Engine app. So we have two. We have the discovery one. Of course, we ate our own dog food and used cloud endpoints to serve the discovery. And then we have our Bira one. So let's take a look at Bira. And we bring that up. And if you look at this endpoint, you'll see a full description of all the types, of all the methods and operations that are part of this. So this is a handy tool, to debug and use. But it's also what we use to create the strongly typed client libraries in all the different languages. In fact, as I mentioned, this uses the same infrastructure that the rest of Google's APIs use. And because we use that same infrastructure, we're able to use tools like API Explorer. So if you do /APIs Explorer, it'll give you a nice interactive view of your API. So those are all the APIs, nicely named. And then I can click on them, and I can execute that API right here from this interactive experience right in the browser without having to write a client. So in this case, this App Engine app has to spin up. But there it is. And you see a well-formatted GET request and exactly what the response is supposed to be. So as Ido and I were building out this application, we found this invaluable tool we could use because I could deploy an application. I could test it independent of his client. He could work, when he built his client, he could play with it, figure out what exactly the payloads were supposed to be. And it was really nice. It was also nice so we could shift blame between us. He would often claim it to be a bug, and I would show that it works nicely in Explorer, so we knew where to put the problem. And it was equally the other way, I'll mention. OK, so that's the basic Explorer. I think we're ready for you to start building out a client.
Absolutely. So as we all know, in software development, we want to take small steps and see that we are on a good path. So first, there's a very, very simple, just plain vanilla JavaScript example. So as you can see here, I'm having this URL. And as Brad mentioned, I want our new service. I want the certain version. And here, in this simple Ajax, you see I just get a payload of the list of beer. Let's see how does it look. Oops.
Oh, did I not switch you? I'm sorry. Failing on my job already, yeah.
Let's see again. How does it look? Yeah, so we got the list of beers. What I said before, and you couldn't see, this is the simple endpoint that I'm calling, and it's plain vanilla JavaScript, so it's simple Ajax call. We have actually, so as you can see and imagine, you could consume it and work with it, and it's good and simple. However, we have another even better thing, and that's Google API JavaScript library, which actually taking some of the load and giving you a better API to work with when you're working in the client. And here, all we need to do, as you can see, is put this script tag and load it asynchronically. And of course, giving it a callback, so when it will be loaded, it will run our case of load API. We could set client ID, API ID, etc., and load several APIs. In our case, we'll keep it simple, but you can imagine how you could extend it and build a big application with it. When we're getting the beers, we have this nice API. And if you remember before, when Brad was making those little changes that make our life easier and more readable, here we're just calling the exact same endpoints, and we're getting the same results. Now, we've built this small test page just so you'll have a sense of how the code looks like and you could play with it. I will just mention that all the code and all the examples that we're showing you are on GitHub, and we'll put the links after the talk so you could take it, fork it, work with it, and join our startup later, right?
Yeah, exactly.
So just feel free. If we're running really fast on examples, you'll be able to tap into them later and just work with them more thoroughly. So let's see the example of just showing the list of beers. So it's work here as well. The code of it is extremely simple. As we saw before, we're just running this entry point, and we're showing the list of beer. Let's see how we could, what we're doing when we're saving, when we're adding a new beer. Basically, it's just boilerplate code to fetch the information from the dialog that will pop up and call the insert. In our case, we know it's an insert when we don't have any beer ID, because we want the server to make a unique ID for each and every beer. If we got a beer ID, we're just calling the update. Let's see how does it look like on the amazing test page that we did. We'll close it so we'll have a bit of real estate. Let's try to add a new beer, VB, because I have a good friend from Australia, and pale ale. And another nice functionality that we'll look at the code in a second is the ability to take a little image here and just drag and drop it. And of course, you could see the geo information that we just got the information from our browser. Let's save it. We got the confirmation. Now we could take this just to make sure it's been saved in our production. And sure enough, it is. And of course, we could remove it. We're getting the answer that it was removed, and now if we'll try to fetch it, we're getting nothing. So we saw basically the crude operations that any app will have to deal with. It's very, very simple and very easy to achieve. I will just show you real quick how. So we saw the insert, we saw the update, and this is what we're doing when we're getting the response back. We'll get the response back in a JSON format, so if we'll have errors, we'll know how to handle them and notify the user what we need to do in that case. I think that we have the basic operations, but with all these social movements, maybe we'll let our friends to have some comments on the beer that we're rating.
Yes, comments. Awesome. You know, client guys always want more features. Have you noticed that?
Trying.
OK, I'm up. So let's go through and see how you would add comments to this app. So we've got beers. I think we should start with comments exactly where we did with beers. We'll just add a new class called comment. And then it's the same story we saw before. We'll go ahead and define a plain old Java object and then annotate it with the JDO attributes. And here I just have an ID for this, the user that made the comment, when they made it, the comment itself. And I'm using the beer ID. So this is effectively a foreign key. It's a which beer is this comment for? And we'll look at that a little bit later. OK, so I take this comment, and I do the same thing. I generate a cloud endpoint for it. So we're going to expose the same sort of REST interface here for comments. So there it is. And now we're going to change the name of that to be Bira so that these sort of are merged into the same API. And now when we look at this list comments method, well, it's going to list all the comments in the data store. But that may not be what IDO wants. IDO's probably going to want a comment for a particular beer ID, right? So what we probably want to do is pass in a beer ID here and have that beer ID return the comments only associated with that. But we have to figure out how to make that work for us in the REST world. So again, our API method attribute is going to be our friend. So let me just import that and grab this code. So what we're going to do here is we change list comments to have a parameter called beer ID. And notice we customized the path here. So I imagine a few of you saw the path earlier and thought, oh, no, I hope they're not auto-generating that path. You have a lot of control over exactly what the REST interface looks like. So you can make it look like the way you need to. So in this case, I thought it made more sense to put the comments logically underneath beers. So beers, the beer ID, and then show me all the comments for that. So that's what I've modeled for you there. So we've done that for list. And then, of course, we need to change the Datastore code. So luckily, it's very easy. We just say beer ID equals, and then the beer ID. And that will do the filtering for us. You could imagine lots more rich logic you could do here. We need to do a similar thing for get. So let's go ahead and do that. And notice here we're passing beer ID and the ID on the REST call. And then we need to do something for insert as well. So, and then I'll leave the others to do offline. But there's just a few just to show you what it looks like. So now we'll run it in the debug server, and we'll take a look at how we test this. So I will test it in curl, as we saw before. Go ahead and try that. And again, the data store has to spin up, so it takes just a second. OK, so there are no items, no comments. That's what we expected. And then what I'm going to do now is add a new comment here for that beer. And then we can go back and look at comments for beer 1 and see if there's any comments. And there is. And then again, in the REST style, I can do for comment too. So that looks pretty good. Ido, I think you're ready to add comments, are you?
Yeah, beautiful. So first, let's see how does it look when we're trying just to add a simple comment to a beer. Great for IO. And then we're doing a simple get. We see all the comments that we had. Let's look at the simple code that does it. So basically, you can see here when I'm clicking on the Save button of the dialog that I just showed you, I'm gathering some information from the user, and I'm getting some information behind the scene, like in the case of the beers, I got the geolocation. Here, I just want to take the exact time that the user entered, and you could think about lots of other use cases. And then I'm just calling the endpoint. Before that, I'm making sure that I have some nice spinner to show the users that some work is being done. And I'm inserting the beer into the app engine, and when I'm returning the call, I'll just show, in case of an error, some alert, and if everything is fine, I'm just showing the list of comments. So we have comments, and it's pretty straightforward. After beers, all the heavy handling been done for us for free in the server side. One thing that I want to show you, we spoke about offline capabilities. How easy is to achieve today an offline capability in terms of doing the initial loading of, let's say, the top 15 beers and saving them locally in our browser. So you could see here that when I'm loading the API, I had this code commented. Now I uncommented it. Let's try and go over it real quickly. Basically, I'm getting a payload of data of items, of beers. And I'm going on each and every one of them. And I'm calling this object that I defined beerapp.db. What basically it does, it's extending launcher and gives us the basic operation that you will expect any layer, any DB layer to do. In our case, it's save beer. Let's try now to run this code from scratch. We'll open the DevTools just to see what's going on, because there are some really nice capabilities in DevTools that letting you see what's going on with your app. Let's load it again. Let's do, OK, we got the beers. Now what you could do in DevTools, which is pretty cool, is go to resources. And in resources, you could go to localhost. And basically, you could see here that I got all the beers with the keys. And Launcher actually did an extra work for me and made sure that I have indexes here. So if I want to fetch a range of beers, it will be quite quickly. Another nice thing that you could see here is that I'm having a global beer ID in my test page. And that's something really useful when you're doing, because even when I'm loading and I'm wanting to work with a specific beer, I could do it quite efficiently, and I don't need to remember what was the last ID that I worked with. So we have the offline capabilities. The sync layer will be in the GitHub repository, so you could check it out later. And let's have a quick look about how the simple code of Launcher is look like. Basically, we're extending it, giving it our own name. And now you could see that, for instance, saving, all we need to do is taking the object, stringify it, because local storage will work with key value of strings, and then just run it and have in the callback the response that everything is OK. If not, of course, we need to inform it to the user. What we did with that is that you all know that the best practices of software development told us to have continuous integration and unit testing. And I want to show you a small example of how we did it in our small use case of saving locally the beers. We created a QUnit page. It is done for you, that letting us know that for each and every change that we're doing, which testers are passing and which are falling. You'll have it in the GitHub repository to look at it later more thoroughly, but it's just one of those things that up to now we didn't have on the client, and now we could run with all the best practices on the client as well as on the server. We have offline capabilities. We spoke about syncing. In that example I gave, and I spoke about 15, 20 beers, I have a good friend that drinks quite a bit. I think if we'll have maybe pagination, it will be really sweet.
Yes. See, again, these client guys with their features. So yeah, so what I showed you before with the beers, so we're back on the server, looking at the listBeers method. It returns all the beers in our data store. Well, that might work fine for this demo, but we're going to have a wildly successful startup, right? So we're going to have hundreds, thousands, millions of beers in Datastore. So we want to support paging of that. And to do that, I also want to show you a few of the other cool capabilities of endpoints. So what I've done is off stage while Ido was working there, I wrote this listBeers method. I updated it a little bit. And I added a couple of nullable parameters. So in endpoints, nullable parameters are optional. So you don't have to pass those in. And so they show up as query string parameters on the URL. So anything you mark nullable will be a query string parameter. And you can have any combination of nullable and required as you'd like. So in this case, I'm going to take two nullable parameters. One is going to be the limit. That is, how many beers do you want to return at this time? And the other is the cursor string, or the cursor. That is, where were you last time you asked? So the first time, obviously, you don't pass anything in for that. The second time, you pass in the result I passed you last time. And so luckily for us, App Engine has App Engine's Datastore has some very nice support for that, which we'll see. So that's the declaration. And then you can see if they pass in a cursor string, then we go ahead and set that in the query. We set the cursor they passed in. If they passed in a limit, we set that as a range. And then what we do is we go ahead and do our execute and get all the results back from Datastore. And then we save off the cursor. So, wherever you were, give me a cursor for that. And then we get a Websafe string. So that's effectively a base64 encoded string that's unique for where this user was, so that you can pass it back at any time and get back the next set of results. So that's really handy to have. And then what we do is we return that. And notice we're returning a complex object this time. We're returning all of those elements as we were before, but we're also returning that cursor string. Yep, so we go ahead and save that. We want to run this in our local development time server. And then to do a test, to do a test of paging, we need to go ahead and add a couple of items to our Datastore. So I'll add Mom's Homebrew and Bob's Indian Pale Ale. So you can see all those are there. And then let's look at all the items in our Datastore. And the local Datastore is a little, OK, so there we go. That's two of them, so that's pretty good. Maybe it'll wake up in a second. OK, so Gary, we have all three of them. We have ID1, ID3, and ID4. For those playing at home, where was ID2? Where was ID2? No, it was the comment that we did. The comment we put in? Anyway, OK. Datastore trivia for you. OK, so there's all of those. And now let's test out limit. So we'll do that. We'll pass a query string parameter for limit. And you see we just use the query string. And notice now we're getting this next page token. That tells us what to pass in to get the next one. And I have already got one of those as well, just to save you from watching me try to type that. And so we pass in the limit and the cursor string, and we get the next one. So Ido, you want to add paging to the app there? Yeah,
it's looking good. In the client, life is good. In our world, all we need to do is to take these two extra params that Brett just mentioned, limit and cursor, and just use them. So if you remember at the beginning when I was calling this endpoint, I was calling just list with none of the parameters. Now I'll use both of them. And basically what we'll do, we'll save the cursor as our pointer. And if we want, we'll know to call it later and just make sure that we're fetching the extra amount of beers. Let's see how does it look like. Let's try to fetch one by one. So we're getting a beer, and then we get the button more, because we know that now we got a cursor back, the next token. And if we'll click, you see here that it's bad, it's VB gold, and we have more and more. So pagination is working quite perfectly. What I'm thinking is that, after all, we're a search company, and maybe we'll have search in our app.
Search. Do you see these features? OK. Yes, let's switch over and see how we would add search to this. And in the process, we'll learn more about cloud endpoints. So App Engine, as you might be aware, recently launched support for search. It actually uses some of the same underlying infrastructure that we use for Google Search. And so if you've studied the search problem, the way search starts is with an index. So we want to create an index of all the items that we want searchable. So here's the basic code to do that index. And we're going to call it beer index. We can set some constraints on it that controls how fast queries go based on consistency, guarantees, and whatnot. But we've done that initialization. Now what we need to do is populate our index. So what we'll do is add a new method here, and we want to customize what goes in the index. For example, we may not want to put the image in the index. That'll just bloat up our index. So we want to have a little bit of customization, which I have written for you ahead of time. So there we are. This is an add to search index method. And what we're doing is just creating a new search document. We're Google, so everything's a document, even if you're talking about beers. So we add a document, and we set its name. And notice we're just pulling these properties right out of the beer objects. And notice sometimes, like name, we're using text. And other times, when we do score, we're setting it as a number. So we're actually telling our search index which things are text, which things are numbers. And that's going to give us some strong query capabilities, which we'll see in just a minute. OK, so that's that basic thing. Now what we need to do is actually add the beers to the data store. So we need to call this method. So let's start up here at the top. Let's see, list is fine, get is fine. Insert, when they add a new item to the data store, we need to go ahead and add that to our search index. Update, when they update that beer, we're just going to add it to the data store. And as long as the IDs match, we need to add it to our index. And as long as the IDs match, we'll be OK. It'll update. So that way our index will stay fresh. And then in remove, we had a bug earlier that Ido so skillfully found at the last minute. And in remove, we need to go ahead and make sure we remove that beer from our index as well. So that's that basic thing. I think we're ready to test that. So I'll just spin up the development time server again, as our pattern is, and then do a search. So we actually need to add a new beer to the data store so that it actually gets indexed. And notice when I add this, look down here at the bottom of the console. You'll see the search engine actually spin up because now we're adding it to an index, so we have to have that service up and running as well. So that search started, so hopefully that means we should be able to query for this and find it. Oh, actually, we can't query for it because I didn't add the query method. Let's go back. We need to, the whole point of that bit was to add this search method to show you doing custom methods in endpoints. So we'll add this, and notice this is a list method that's similar, but we're exposing it as an HTTP GET. So you get to customize the verb just like you get to customize the path. We pass in a required argument for the query string, and then all we're doing really is passing that query string to our search index. The search results come back, and we pull out the index from the search results and call that get beer method that we defined before that we'll call Datastore get our beer, and then we return the whole list of those. OK, so with that, we should be able to so we've added that item to the data store. Now we need to search for it. So we'll search for that cool beer, and the search engine will start again. Oh, yeah. OK, I tell you what, let's because I had to start and restop, let's skip ahead to this part. So we added a couple of different beers with score ID 11, score ID with score 9, so with various different scores. And I'll show you searching for those. So notice that the search can be pretty powerful here. We can say the score equals something. So we actually can do math here. So I could actually say where the score is less than this. So you can see this, coupled with the fact that it actually does Boolean operators as well, gives you some really powerful query capability for this service. So with this done, Ido, I think we're ready for you to take off. And,
Perfect. Yeah. Excellent. So they said that simplicity is the ultimate sophistication. And I think in that case, you must agree with me that it's pretty simple, that piece of code that we have in the client. Basically, what we're doing here, you could all see it good. I could make it larger. You see it well? Maybe even larger. Basically, we're listening to the Keydown event. In our case, we want to catch the enter when the user is finishing to click the term in. And then we're just taking the payload, the search term, passing it to the search endpoint. And let's see what's going on here when we're doing it for real. So you saw here that I just put a breakpoint in DevTool. How easy now to inspect and see what's going on and what we got back from the server. If you'll hover, you'll see that we got an array of items. We could dive into them, see exactly what's going on. And when we are happy, we could just release it and see that we got a list of beers that we wanted. As Brad mentioned, it's much more powerful than just that. You could do things like that. And then let's leave it so we could run properly and get all the beers that are from score 3 and above. And we could do even better than that and go and play with some geo queries like this one, which basically will give us a view of beers around us or around the user of our app. Here I cheated a bit and I just gave a map that mimic what the functionality will be like. But you could see how easy is it to use the search from the client and get some sophisticated queries that you don't need to code anything in order to achieve them, and slice and dice the data that you have in your app in some clever ways thanks to the search capabilities. Now, I don't know, I have a few more requests, but I think it's maybe time to production. Yeah, maybe we could deploy it.
OK, ready to deploy to production. OK, great. So it's very easy to do this. We have a set of command line tools and stuff so you can script them. But as a developer, it's nice that right from Eclipse, you can go ahead and deploy this. So while Ido was talking, I went and set the application ID for this. So if you just go to appengine.com, everybody can get 10 free apps that have a pretty generous free quota, and it's free and always free for that tier. So you can go get your ID. I got Bira IO 2012. And then you just click deploy. And what's going to happen now is it packages your application locally and sends it up to the server for deployment. And this only takes max 2 or 3 minutes of our normal Wi-Fi. So let's let that go.
Maybe I'll just show them the web intent that I forgot.
Oh, sure, yeah. You want to switch back to web intent?
Yeah.
OK. And by then, this will be done.
I'm really passionate about this small operation, and I just wanted to show you how easy is it to hook it up to your apps. So basically, with web intent, we're letting the user choose how they want to achieve an intent, an action. In our case, let's try and share our beer. So as you can see here, from Chrome 19 and above, it's natively in the browser. When I'm clicking share beer, I'm getting few options here that I found myself using a lot, but you could add, and there's plenty of more in the Chrome Web Store to check around. And in my case, let's see how it's done. I just want to send it through Gmail. So you could see the payload. In my case, it's just the beer name, the score, and maybe some link back to the app. Very simple. And the power of it is that, check this set of lines that's making our life so much easier. So we're gathering in beer details the payload that we want to send the intent. Then we constructing a new intent, and it could be share, it could be edit a photo. So let's say that you want to let your users edit the photo. You don't need to code this again and again and reinvent the wheel. You could use other services out there that are focusing and doing this work and excel in it, and just let the user tap to them. And then we're passing the beer details. And when we're starting the window.navigator object, we're passing the intent, started the activity, and the user is taking it from there. Very simple, very smooth. And of course, we have JavaScript themes to all the other browsers. So in Chrome, it's coming natively. In other browsers, the user could achieve it with the JavaScript themes that we have.
All right, awesome. So that gave me plenty of time to deploy the application to production. Just give you a sense of what it does. Some client-side stuff. It uploads all the files and then verifies that it's available, updates all the index, and it's deployed. So as soon as it's deployed, the next thing we wanted to do is actually go do some scalability. Well, don't do it yet. Well, whatever. What we wanted to do is do some scalability testing of it. So we used Apache Bench, and it was this is just very basic, off-the-cuff scalability to give you a sense of how this works. Apache Bench is a widely used open source tool for doing this. So we did 9,000. This was on my laptop, on our Wi-Fi network at work. So we did 9,000 connections, 100 at a time. And you see the results we got in percentile here. So 90% of the requests came back in less than half a second.
It's not showing.
Oh, it's not. I'm sorry. Great, thank you. So now you see that we used Apache Bench. We got 90% of the requests came back in half a second. So that's pretty decent. That's pretty good for sort of in the wild deployment. And again, we didn't have to do anything to make our app actually scale that way. So then the next thing I did, I don't know if you caught in the keynote, we launched a new sister project to App Engine. Does anybody remember what that was called? Compute Engine. I don't know if anybody knows anything about our data centers. One of the things Google does pretty well with the data centers is networking logic. So I thought it'd be fun to get a Compute Engine instance and just see how quick that would be to hit the App Engine app from a Compute Engine instance. It turns out they're actually in different data centers. The App Engine app was running in one data center, and the Compute Engine was running in another one. But anyway, it's fun nonetheless to see that 95% of the requests came back in less than 7 milliseconds. So it's actually pretty fast. So if you're doing something, you want to access your App Engine app quickly, this is the way to do it.
Rate a lot of beers.
Yeah, it turns out that the way this actually works with App Engine is a lot of this is static content coming from the HTML app, and that gets stored in Google's distributed cache. So it turns out it wasn't actually hitting my App Engine app at all. It hits it one time to get the HTML, and then after that, it serves it out of the cache, and those caches are distributed globally. And that's available for all App Engine apps. You sort of get that for free. So once we figured that out, we thought we were actually playing around with this with different arguments, had a couple of machines playing around with it, just to see sort of where we could get the queries per second. Like if you've seen the App Engine graphs, like how many simultaneous requests could we get? We got a little crazy with the Apache Bench tool, and we got to 6,000 QPS just playing around with a couple of machines. So that's pretty good, and it's literally the code you saw today. Again, a lot of the QPS is actually hitting the HTML page, but it's really nice to be able to know that you're working on infrastructure that you can just play around with and get to 6,000 QPS. To give you an idea, 6,000 QPS is like 250,000 requests a minute. So what is that? Maybe a few 100,000 concurrent users. So just think about if you're going to stand up your own machine to go serve 100,000 concurrent users, that might take you a little while. You might have to think about some sharding and whatever, and we've done all that work for you with App Engine. So
main takeaways. I think we saw that it's pretty nice today to be a developer in terms of the development experience. With Google App Engine, you could leverage and tap into the infrastructure and write your own RESTful APIs quite easily. One of the nice things is that not only you don't need to think about scalability, you could focus really on the API. The API is, in most of the cases, the most challenging aspect of all the system itself. So now you could just devote the vast majority of your time to that critical section. And of course, code it from the client side with all the best practices of HTML5 and the newest API that are under your hands. And I think we mentioned a few very important points that I would urge people just to keep in mind when they're building their next modern web apps, mobile or desktop. One of the most important features is, of course, the 60 frames per second and the smoothness. And that's coming with option to make the app working offline. And lots of users and lots of great apps like the Financial Times, the New York Times, Google Docs, Gmail, and so on are enjoying it today. And in the near future, we'll see more and more users expecting it. So that's something to keep in mind. Web Intent we show you, you have no excuse not to use it. It's so simple and trivial. And I would really like to thank you to come us and hear us after the heavy lunch that we had. Both Brad and I will be in the sandbox. If anyone have more questions, after we'll have, of course, the section for questions. And as I mentioned before, you could have all the source code of all the examples just to play with them and see exactly how it's working for you in this GitHub repository. We'll put the slides once.
Oh, goodness. I'm sorry. You guys got to help me with this.
Yeah, so you have the link to the GitHub repository. The code is actually there. We'll have all the slides and other documentation below it. And of course, you could try and test the app itself and the endpoint itself in Bira-IO 2012. hit it as hard as you want. We would love to see some nice graphs on it. And of course, check out the Endpoint, the new Endpoint API. It's pretty powerful. If by any chance you didn't reach to Brad or myself after the talk or in the sandbox, please feel free to use our G+. We both would be happy to answer any question that you might have or challenging or problems that you might have in the near future. So thank you very much. And if we have questions, we'll be happy to take them.
So if you enjoyed this show, we'd love you to vote with your little plus ones. Ido and I are always looking to get better. So if you have comments, there's a URL in the back. So
absolutely.
Thank you very much.
Thank you.
So should we just do questions here, or any questions?
Sure.
Anybody?
If you ask an easy question, you're getting a sticker. If it's a hard one, no sticker.
I was wondering if there's any plans on bringing client-side adaptive images into App Engine.
You want to take it?
You mean, what do you mean by adaptive images?
Serving up different resolutions for the multitude of devices we now have.
Yeah. We have heard that. There's nothing that I have right now for you, but.
What you can use today is just, you'll need to do the legwork, but we have, of course, the API to use it, but you'll need to do the legwork for it.
Okay, thanks.
And you could get a sticker.
Yes, please.
It wasn't hard. Yes, please.
Do you guys have any best practice recommendations? I saw you get bit by it a few times where when you're in an application going page by page, wizardy style things, you have to wait until the data store has your data before you can then requery it back in page 2. And like you said, it's not there yet. You got to wait a second and then try it again. When you're in an application, is there a better way or a notifying way to then be told, my data's there, now I can move forward?
Yeah, absolutely. And actually, that's one of the benefits of building your app from the ground up with offline in mind. Because then you'll know that you have the most common data that the user is using, and you could make a nice heuristic about what he will want next and just fetch it immediately from the local storage. And that's actually why we see lots of apps that are really snappy and really fast, because they don't need to do the round trip to the server and fetch the information in order to show it. They already have it locally.
So you're saying you just keep it locally and don't actually put it in the data store until later?
Yeah, so do everything locally first, and then sync it when you have time for it. And when you have the right connection, the right bandwidth. I saw some modern web apps that actually checking how good the connection is. There are a few JavaScript libraries that let you do that, and then doing the syncing just in the right time. So that's one thing. The other thing is that with Google JavaScript API library, you could tap and do batch requests. So you using and leveraging one connection with multiple requests on top of it, and that's, of course, working much better.
Okay.
You could have a sticker. It was hard, but we made it.
How do you handle security and privacy, in particular, like in a healthcare setting, if you're writing a healthcare app, HIPAA regulations and all that sort of stuff?
That's a great question, so you'll definitely get a sticker. We haven't showed it because we didn't have time, but authentication is coming out of the box. So it's perfect, and the question is actually amazingly good because in other cases, you need to work pretty hard to make your app secure. And in our case, both the endpoint is supporting the cross-origin sharing resources and authentication just out of the box. So we'll have in the code actually in GitHub, and you could see how easy is it to have, let's say, authenticated comments or beers. So only users that are authenticate could actually work with the app. So in terms of security, you're getting quite nice things that are already been done for you. So you don't need to work for them yourself.
Yeah. I can show you an example if you.
Okay, so behind the scenes, are you indexing Google? Is Google indexing patient data or whatever information I'm storing? Or
no. Let me do this one. No, it's very clear in the App Engine terms of service. We can't even see the data that you're putting in App Engine. The only thing we can do with the data that you're putting in App Engine is serve it back to you. So we're not indexing it in any way. It is completely your data.
Okay, thanks.
Sure.
Okay, one more probably, yeah.
Yeah, they will turn the light on.
You get to be the last question.
Right on. Hopefully it's an easy one and I'll get a sticker.
Hope so.
WebSockets on App Engine. When is that going to be available?
Stay tuned. Stay tuned. Yeah.
Good.
I'm holding my fingers as well.
Nothing to announce right now. Okay. Well, that was so easy.
That was a short one. there are a few annotation APIs like JAX-RS or something like that. I wanted to ask you what is add API method, and what about existing standards?
Yeah, so we discussed this. We decided to, so add API methods are ones that we created for our cloud endpoint. Because there's a lot of things that's very custom to that. We definitely think it's possible to layer on top of that a standards-based approach. And if somebody's interested in doing an open source project around that or whatnot, I'm happy to discuss some of the details with you.
Okay. Thank you.
Okay.
Thank you very much.
All right, cool. Great. Thank you, guys.